In this video, we are going to be using inverse trigonometry to solve right triangles. Inverse trigonometry is going to help us solve for missing angles. So to solve a right triangle means that you come up with measures for all three sides and all three angles. So for this example, okay, now when we're talking sides in lowercase letters like this, it means the side across from angle D. So if we take a look at angle D, across from that is 17, so this would be considered side D. So this one is 17. E, so here's angle E, across from angle E is side E, which is 8. And then we would need to find F. So when you've got 2 out of the 3 sides, you can revert back to using Pythagorean theorem to find the missing one. So remember, Pythagorean theorem is c squared equals a squared plus b squared. So then we'll type in 17 for the c, so 17 squared, a squared and b squared can be in any other order, so 8 and f squared. 17 squared is 289 equals 8 squared, which is 64, and then plus f squared. So then we'll subtract 64 from both sides, and this would be 225 equals f squared. Then we can square root both sides, and the square root of 225 is 15. So we get 15 for side F. Whoops. So then for the angles, okay, so angle D is the 90-degree angle. Angle F is 62 degrees. And then we just need to find this third one. So remember that all the angles total 180. So we'll subtract 90, which will get us 90. And then we'll subtract 62, which will get us 28. So 28 is how big angle E is. So in this case, you don't have to use any trig. You can just use Pythagorean theorem to find F and then just subtract from 180 to get that missing angle. So if we have 2 angles that are missing, then we need to use what's called inverse trigonometry. So remembering back to So-AH-TOA, to remember what sides go with what function, this is how you work it backwards to get the angle out. So if you set up a trig function and you end up with this, tangent of theta equals 4 over 5, okay, if that angle is the thing that's missing, then we're going to be using inverse tangent to get the angle back out. So you'll use inverse sine when you have the opposite and the hypotenuse. You'll use inverse cosine when you have the adjacent and the hypotenuse. And you'll use inverse tan when you have the opposite and the adjacent. So let's take a look at what this looks like in an example, okay? So in this example, it says, what is the measure of angle A what angle A is created? So what's the measure of angle A when the right triangle has an opposite side of 28 and a hypotenuse of 35? So remember that the opposite side is directly across from the angle. So we have A here, so opposite is going to be 28. And then the hypotenuse is always directly across from the 90. So this hypotenuse is 35. So remember, we'll take a look at So-AH-TOA to decide what function we're using. And in this case, again, remember we have the opposite O and the hypotenuse. So we're looking opposite and hypotenuse. So that's going to be the sine function. So we would set up a sine function. Sine of theta equals opposite over hypotenuse. So we'll plug in what we have here. So sine of A, which is what we're looking for, equals the opposite side, which is 28, over the hypotenuse, which is 35. So you'll notice in this case, we don't have a variable in this fraction. The variable is inside of our function. So in order to get that a back, we'll just do the sine inverse to both sides. Because then the sine inverse of sine cancels. Okay, so we're going to get back a. And then on this side, we would have the sine inverse of 28 over 35, which we will just type into our calculator. So go into your calculator, hit functions, and you'll see sine to the -1. So this is sine inverse. Oops, I got to clear out the rest of my stuff here. Okay, so sine inverse, and then go back and do 28 divided by 35. And then it'll tell you that that's for a 53.13 degree angle. So A is 53.13. So if you wanted to do to the nearest degree, A would be a 53 degree angle. Example 2, so take this triangle, it's giving you the measure of P is 90 and O is 55, OP is 22, so let's find the measure of angle O. So I'm still going to circle this angle. This is the angle in question, and we're going to look at So-CAH-TOA. So we're going to label the sides again. So opposite would be PN, which has nothing. Okay, directly across from the 90 would be the hypotenuse. So 55 is the hypotenuse. And then next to the angle that we're looking for is the adjacent. So we have the A and the H. So an AH function is cosine. So we will do cosine of theta equals adjacent over hypotenuse. So cosine of the angle, in this case we're calling it X, equals the adjacent side, which is 22, over the hypotenuse, which is 55. So then we need to get the variable out of the cosine function, so we'll do cosine inverse to both sides. So cosine inverse of cosine just gives you back X. And then on this side, we have cosine inverse of 22 over 55, which we'll just type into our calculator. So cosine inverse, cosine inverse of 22 divided by 55, and you'll see 66.42. So if we wanted to do to the nearest degree, we would say 66 degrees. Again, C is 90 degrees, BC is 24, CA is 86. We've got that labeled on here. What's the measure of angle A? So we'll identify the angle, okay, and then we'll label the sides. So 24 is the opposite. Next to it is the adjacent. So we'll look at So-CAH-TOA. To decide what function to use. So opposite and adjacent is going to be your tangent function. So we'll have tangent of the angle equals the opposite side over the adjacent side. To get the angle back out of the function, we'll do tan inverse to both sides. So tan inverse of tangent of X is just X. And then we have tan inverse of 24 over 86 on this side. We'll type that into our calculator. So tan inverse of 24 divided by 86. And you get 15.59. So if you needed nearest tenth, it would be 15.6, which is what this problem said to do to the nearest tenth. All right, solve the right triangle means find all three sides and all three angles. So we need this missing angle and these two sides, okay? So let's go ahead and work with this given angle of 18 to label the sides. So this X side over here is the opposite. This 20 is the adjacent, and the Y is the hypotenuse. Now, in this one, we're actually going to need to solve for two sides, so we're going to have to set up two different functions. So when you do this, you don't want to use both variables at the same time. So I don't want to use the opposite and the hypotenuse, which would be a sine function, because if I do that, I'll get sine of 18 equals the opposite x over the hypotenuse y, and you can't solve that when it has two variables. So what I'm going to do is use the opposite side and the adjacent side first. And I'm going to set up a tangent function for that, for opposite and adjacent. So tangent of 18 equals the opposite x over the adjacent 20. So then you would just type in tangent of 18 into your calculator, and you would get 0.3249 equals x over 20. Make this into a fraction so you can cross multiply. So do 20 times 0.3249, and you would get 6.49 equals x. So if we rounded to the nearest tenth, x would be 6.5. Then we can go ahead and solve for y. This is the hypotenuse, and we'll still use the adjacent given side. So adjacent and hypotenuse is cosine. So cosine of 18 equals the adjacent side 20 over the hypotenuse y. So type in cosine of 18 into your calculator, and you'll get 0.9510 equals 20 over y. Make this into a fraction so you can cross multiply. So you'll get 0.9510y equals 1 times 20, which is 20. Then you can divide by 0.9510 to both sides. And you'll get y equals 21.03. So to the nearest tenth would be 21.0. Then for your angles, okay, so for your theta, remember all three angles, we've got two of them. We've got the 90 and the 18. So to find the missing angle, we just subtract those from 180. So we'll do 180 minus 90 minus 18, and we will get 72. Okay, so solve this right triangle. So now this one has two sides given to you, and you're looking for the third one. Okay, so there you can just do Pythagorean theorem because you know 2 out of 3 sides. So we'll just do c squared equals a squared plus b squared. So c squared is the x, so x squared equals, and then you can put the 15 and the 5 in any order you want. So we get x squared equals 225 plus 25. Add those together and you get 250. Then you'll square root both sides and you'll get x equals 15.81. So if we were doing to the nearest tenth, we would get 15.8. Then to find the angle, okay, just decide which angle you want to find first. It doesn't matter. Alpha, which is this fish-looking one, or beta. So I'm going to do alpha. So I'm going to circle it just like we always have, and then I'm going to label the sides that are given to me. So I'm going to label the 5 as the opposite because it's directly across from alpha. So this is the opposite. And the 15 is the adjacent because this is the hypotenuse. So then we're going to go to SO-CAH-TOA and figure out which function uses the opposite and the adjacent, which is the tangent function. So I'm going to say tangent of the angle, which is alpha, equals the opposite, which is 5, over the adjacent, which is 15. So now I want to get alpha out of there. So I will do the tan inverse to both sides like we've been doing. That way the tan inverse and the tan cancel and you get back alpha. And then on this side you have tan inverse of 5 over 15. And you'll just type that into your calculator. And get that alpha equals 18.43. So to the nearest tenth, 18.4. Now you've got the 90-degree angle and the 18.4. So to get beta, you can just subtract both of those from 180. So 180 minus 90 and then minus 18.4. And you'll get 71.6. All right, last example here is a word problem. So Mrs. Heinzen is 27 feet from the goal line when she shoots the puck directly at the net. The height of the goal is 4 feet. Draw a picture of this situation and then write and solve an inverse trig equation to find the maximum angle of elevation that she can shoot the puck. Okay, so here she is, this many feet from the net. Okay, and then the height of the net is 4 feet. What angle can she shoot the puck at in order to make the shot? Okay, in order to not hit the pipe and have it go underneath and into the net is what we're looking for. So this is not drawn to scale, but she's 27 feet from the net, and then the height of the net is 4 feet. Okay, so the horizontal and the height will make a 90-degree angle, and then we're looking for this angle. So label these sides. So across from theta is the opposite. Next to theta is the adjacent. So that would be from So-CAH-TOA we would look at. And that's going to be a tangent function. So we'll do tangent of the angle is equal to the opposite side, which is 4, over the adjacent side, which is 27. Then we would do the tan inverse to get the angle. So you'll type that into your calculator and you'll get 8.42 degrees. So Ms. Heinzen has to, the highest angle of elevation she can hit is 8.42. That would hit right on the pipe, right on the top of the net. Okay, so she has to hit less than an 8.4 angle of elevation to still make a goal.